Hello! In this video, we are going to prove the following theorem. Suppose f is a function from a to b and c is a subset of a. Then, 1. The restriction of f to c is a function from c to b. And 2. For all elements x in c, we have that the restriction of f to c evaluated at x is equal to f of x. Now, remember, the restriction of f to c is defined as the intersection of f and c times b. Okay, so we're going to prove 1 first. We're trying to prove that the restriction of f to c is a function from c to b. So there's 2 things we have to show. The first thing we have to show is we have to show that the restriction of f to c is a subset of c times b. And second, we have to show for all elements x in c, there is a unique element y in b such that x comma y is an element of f restricted to c. Now, this first statement is pretty easy to see on its own, because if you consider any element of f restricted to c, then by definition, what that means is you're an element of f and you're an element of c times b. Therefore, you're an element of c times b. So now, all that's left is to prove that this second condition holds. So, we're trying to prove a statement about every element in C, so give me an arbitrary element of C. I'll call it X. We want to show that there is an element Y in B such that X comma Y is an element of F restricted to C. And then we want to show that that element Y that we found was unique. So first, let's prove existence. Right? Let's actually find an element in B such that X comma Y is an element of F restricted to C. Okay, so to start, since X is an element of C and C is a subset of A, it follows that X is an element of A. So X is an element of A. But since F is a function from A to B, it follows that F has a functional value at X. We could say, for instance, let Y equal F of X. And of course, y is an output value of the function f, so y is an element of b. And remember, this is another way of saying that x comma y is an element of f. So x comma y is an element of f. But notice, we have that x is an element of c, and y is an element of b. So it follows that x comma y is an element of c times b. So since x comma y is an element of f and c times b, that is to say, x comma y is an element of this set, which means x comma y is an element of f restricted to c. And at this point, we have found an element in B, namely y, such that x comma y is an element of f restricted to c. So that proves the existence of this object. So now we want to prove that this element y that we found is unique. That is, we want to show that y is the only element in B, such that x comma y is an element of f restricted to c. And the way we're going to prove y is unique is we're going to prove that every element in B that satisfies this condition is equal to y. Right? And that would tell us y is the only element in B that satisfies this condition. Right? So give me an arbitrary element in B that satisfies this same condition as y. I'll call it z. Our goal is to deduce that z is equal to y. Now, since x comma z is an element of f restricted to c, it follows that x comma z is an element of f and c times b. In particular, we have that x comma z is an element of f. So notice, we have that x comma y is an element of f and x comma z is an element of f. Since f is a function, x must map to a unique value. In other words, we must have that y is equal to z. So we gave ourselves an arbitrary element in B that satisfies the same condition that y satisfies. And we proved that it must be equal to y. That proves that y is unique. So there is a unique element y in B, such that x comma y is an element of f restricted to C. And since x was an arbitrary element of C, this means for every element x in C, this is true. So we have proven the second part, right? Because we've proven both parts, this is exactly what it means for f restricted to C to be a function from C to B. So we have proven that f restricted to C is a function from C to B. So now we're going to prove 2. Now, we're trying to prove a statement about every element in C. So give me an arbitrary element in C. I'll call it x. Now that we know f restricted to C is a function from C to B, it follows that f restricted to C has a functional value at x. And we could say, let y equal f restricted to C evaluated at x. And remember, this is another way of saying x comma y is an element of f restricted to C. But remember, if you're an element of f restricted to C, then you're an element of f, and you're an element of C times B. In particular, you're an element of f. So it follows that x comma y is an element of f. But remember, f is a function. So another way of writing this is to say y equals f of x. So we have that y is equal to f restricted to C of x, and y also equals f of x. Therefore, f restricted to C of x is equal to f of x. So, putting this together, we gave ourselves an arbitrary element of C, call it x, and we proved that this statement has to be true. Since x was arbitrary, this means for every element in C, this is true. So we have proven number 2. So this completes the proof. And so yeah, that's pretty much it for this video.